How does gravity work? In the 1600s, Isaac Newton developed the universal law of gravitation, describing it as a force of attraction between objects that decreases with distance. And Albert Einstein, in the early part of the last century, developed the concept that matter curves space around it, and this is why there's a force of gravity, as well as correctly predicting the existence of things like black holes and gravitational lensing of light. This concept has been verified by abundant observational evidence. This gives you the tools to show the basics of how gravity works without bringing in mathematics or advanced physics. Let's start with falling down.
Jump. Jump again. Why do you fall back to Earth every time?
Gravity.
What is gravity?
The stuff that holds us down?
That makes us fall down. Why is there a force of gravity? Can you throw a ball so that it doesn't come back down to Earth?
No.
Albert Einstein, in the early part of the last century, developed the concept that matter curves space around it, and that is why there's a force of gravity. Let's see what that means. This is space, the fabric of space. There's space all around us, everywhere, in all directions. This just represents one small portion of space. Einstein said that massive objects curve space around them. Let's use this weight to represent Earth. Put it in the middle of that space. What happens to space when we put Earth in it?
It curves.
Exactly, it curves. Now, let's say this is the sun.
Ooh.
How much is the space curved around this?
A lot more.
A lot, right. The sun has more mass than the Earth. What is mass?
Weight?
It's how much material is in something. So the sun is more massive than the Earth?
Yeah.
Now, this is a model and is not to scale. The sun is actually a lot more massive compared to the Earth than this ball is to this ball. These marbles represent small space probes. If we place one probe at the edge of this bucket and one probe at the edge of this bucket, which probe will fall towards the middle faster?
This one.
Why?
Because there's more gravity.
More mass, more gravity, more curve. Let's try. You try it. So what happened? Which marble fell faster?
That one.
Yes. So this is what we mean when we say the force of gravity depends on how much mass is present. Mass curves space. More massive objects curve space more or less?
More.
More. So the force of gravity is stronger or weaker?
Stronger.
Yes. We said space is curved around Earth. If you jump off Earth and end up here, are you going to stay here if I let go?
No.
No. So why do you fall to Earth when you jump?
Because of gravity.
Because of gravity, the curvature in space. You can extend this activity by taking two marbles of different sizes and dropping them both at the same time into the Earth. If fingers are wet or sticky, both marbles might not be released at the same time. You might prefer to use a card, like a business card, to hold the marbles back. You'll notice that both marbles fell into Earth at the same speed. Space is curved around Earth, the same for both marbles, so they fall at the same rate, even though one is heavier than the other. You can then take one of the weights and a small marble and drop them to the floor to illustrate that what happens with the bucket is the same that happens on Earth.